All right. So on the notes, showing you exactly what you need to type in. You will not have to worry about the subscripts. Desmos will take care of that for you. And we'll see that here in a minute. So, looking at the first problem, a mathematics teacher wanted to see the correlation between test scores and homework. The homework grade are your X values, the test grades are your Y values, and they're given in the table. Write the linear regression equation. You may also see linear regression model that represents a set of data, rounding all coefficients to the nearest 10. So you definitely want to pay attention to what it tells you to round to. So first of all, we're going to create a table in Desmos with this information. Okay? So to create the table in Desmos, you click on the plus sign right here. And then you have all of these options. So then you pick table. And then you enter the X and the Y information. So 77. And you can do however you want. You can enter all the X and then go through and enter the Y values. You can enter each pair at a time, however you want. Okay, so I have that information, but I don't see my data. So then the next thing you want to do is you have this little zoom tool right here. If you click that, it's going to zoom to your data. It'll do that every time. So that's something you want to do. So then you can see and get an idea. You lose your X and Y axis because it zooms out too much. However, it still leaves you with the actual, what the grid lines are valued at. Okay. Next is the model. Well, if you're told to pick the best model, I would say that trends linear. There's no curve to it showing it's going to curve over. So I would say that's a linear trend. So then in line 2, we're going to just type Y1. You don't have to put Y sub 1. You don't have to use a subscript. If you just type Y1, it automatically puts it as a subscript. Then above your tab button is that symbol. So this is, we're typing in the linear model that's listed at the top of your notes. And then we're going to do MX1. Again, it automatically put it as a subscript. Then plus B. So linear regressions are the only ones we're not going to see the H and the K that we're used to seeing with all the other models. Okay? So if you look at the statistics of it, you see these R values. Okay? All that tells you is how close a correlation you have. The closer it is to 1, the better the model. All right? So we want these rounded to the nearest 10. So with our slope of 0.4693 to the nearest 10, 0.5, with our y-intercept of 30.811. So the nearest tenth, 30.8. So in other words, you don't study for the test at all, you don't do your homework at all, you're going to get about 31% on that test. And that's what that's saying, which is not great. All right, so with those two pieces of information, we're going to go back and fill that in our notes. Okay?
What you're saying is I should study.
Yes.
There you
Yeah.
go. All right. So filling those pieces in, we have 0.5 and 30.8. So y equals 0.5x plus 30.8. So that's all. You're putting the data in the table. You're having Desmos create the equation for you. Then you're going to use that created equation to answer questions. No drawing these by hand. No trying to find the line that fits the best. Desmos is going to tell you exactly what fits the best. We'll take one for next time. On your homework, I believe it tells you, but we'll go through and look at the models to see how they go. So, using that equation, let's answer the next two questions. Using the equation above, estimate the test grade to the nearest integer for a student with a homework grade of 55. So, X represents the homework grade, Y represents the test grades, yes? Okay, so then 55 is an X value. So Y equals 0.5 times 55 plus 30.8. Do the math of that. Desmos also works as a calculator. So if you type in in line 3, 0.5 times 55 plus 30.8, it'll give you that answer as well. So we want nearest integer, so that's 58.3. So the test score that we're going to use and answer with is 58.
Wait, so what's an integer?
No decimal. So you would round to the ones place.
So if it was 5, it'd be 59.
If it was a 0.5 at the end, then it'd be around to 59. Okay, so if for a student with a test grade of 89, what were their homework grades?
It's the opposite.
So, yep. So 89 goes in for Y. So solve for X. So we would subtract 30.8 from 89 and then divide by 0.5. So that's what it's estimating. So in other words, that student got a lot of extra credit. So that's the other piece is sometimes, because the way the model is set up, it doesn't get it 100% exactly right. Yeah. So again, it's a model based on that data, so it's not 100% accurate, but it's the best guess based on the data. So if we look at quadratic, these are the ones that you're going to see the A, the H, and the K in the model. So we're going to do the exact same thing with this information. We're going to enter it in the table. So a couple different things we can do. One, we can just delete these boxes completely and start a new one. It's usually the easiest thing. Table. And now we enter that information. So 47, 143, 215, 283, and 326. All right. So again, this isn't, if you want to go back to home, you can do that. And this home button that was down here, it takes you back to the original configuration. Or just from the previous place, zoom to fit your data. All right, so that one is looking pretty linear to me. Okay, however, so what those, take a look at the rocket is shot off from a launcher. The accompanying table represents the height of the rocket at given times, where X is time in seconds and Y is height in feet. So, is a rocket going to continue just increasing?
No, it's eventually going to die out.
Yes, it's going to die out. It's going to create that parabola. So even though the data doesn't look like it that we have recorded, we know the way a rocket will go is it's going to go up to a peak and it's going to come back down. The other thing, if you're looking at your data and it doesn't tell you which one it is, if they give you enough information, you're going to want to look for the curve that changes and goes back down. Or if it opens up, the curve that starts going back up. Okay? So this time we're going to type in the other model that's on the front of your notes. You don't have to, you can just Y1, it automatically assumes the sub 1. Again, it's not equals. So then we have our A, X1 minus H, don't forget the square, then plus K. There's the model. Okay. So you can see as it's dying out, Also looking at the data, you have a pretty good rapid increase. And notice that increase is getting smaller and smaller as it's going up to the peak. So that's one of the other things you can look for. All right. So, well, that's a spot on perfect fit. 1. Doesn't get any better correlation than that. So, with those pieces of information, our A, we want to record those pieces. What did they say to round to? Nearest tenth again?
Here's 100.
100. Okay. So this time we want 2 decimal places. So our A, negative 14.32. Our H, 5.44. And K, 425.09. So we're going to type those 3 or write those 3 in. Okay, so then the equation y equals negative 14.32 x minus 5.44 plus 425.09. All right, when you're in, whoops, let's start square. There we go. Again, it's a quadratic, so there needs to be that square on it. Using this equation, find the height to the nearest foot. So again, no decimal place when you round at this point. At a time of 3.2 seconds. So our x is 3.2. With quadratics, you're always going to be finding your y value when you use these equations. We have another unit 5 coming up, where we'll actually solve for y. Okay, let's plug this in. As long as you are careful with what you do in the parentheses, you could do this all in one line. And we get approximately 352.24 feet. So round to the nearest foot, no decimals, 352 feet. That would be your final answer.
We got 430.
430?
Yeah.
Did you get 430? Let's see. Let's check it. Let's speak. Let's double check. Okay. Let's see what I've typed in. Negative 4.32. 3.2 minus 5.44, that's squared, plus 425.09. You said 14. Did you put the 1 in there? Oh, whoops, 14. That would be it. Let's double check that I did that. Yep, negative 14. Yep. All right, so going ahead and all right. So again, when you're doing these, this home button here, the little one looks like a house, takes you back to the original configuration. It always does that. So, adding your table. I'm going to go ahead and add the other one. So you can have 2 of them at the same time. If you click on the color, the table would still be there. It's just not showing up on the graph. Okay? I can zoom to fit that data. So there's the green. This data is on there, but it's not showing up because it's much higher. So that is going, what would you say that one is? Linear or not?
Linear.
Linear.
It's definitely linear.
So what we can do to determine if it is, just do a double check. We can type both of the models in. Now my first one uses Y1. So I'm going to type both the models in right here. There's that one. And type the other one in. Okay, so looking at that, I have a better fit. Now granted, technically, they're both pretty close, right? But does it make sense that my graph curves over on this negative side when there's not any data sending it there? So sometimes you do find a model that actually both of them kind of fit closely. But looking at the trend of that, the trend of those points is definitely linear. So I would not use the quadratic.
So if they're just not a shape, like we can look at the numbers and tell if it's linear.
Yeah, you are going to be able to look at the graph and know which one you're going to use. You won't have to look at the R value, but you'll know which one. Okay. So most definitely linear. The trend is a linear. So if I turn this one off, the only reason I would want to turn some of these tables on and off is if the data is showing up in the same area. This data is not showing up in the same area because there's nowhere. But there's that data. What would you say that shape is? That's definitely quadratic. Man, if you look at your table, your data is increasing to about 724 and then it's decreasing again. So you have that traditional parabolic curve, increasing to decreasing. Those are those obvious things you want to look for with your data to know which function you're going to do. So this one should be a little more obvious This is y2, remember, because it changed it, new table, since I put both of them on the same thing. So that is a terrible R value. That's not even close to 0.1. That is terrible. 0.004. Those are terrible. This 1.99, much better. Okay, so that one in red clearly goes with that data. From the R values, it's very obvious which one you should use. So when you're in a testing situation and they don't tell you which model, because that linear one technically could work as a quadratic as well, make sure you're justifying your reasoning on the model you're using, and especially if they give you a situation. So if they give you a situation that the rocket is going up, these are the measurements, come up with an equation that models that, you most definitely should use a quadratic. Because those are the ones that have the curves. The rocket goes up and then it comes back down. Okay? All right, so when you're picking your model, that's the things you want to look for. Now, practice. So, as we're going through, on 4, we decided the linear model was the best. And number 5 was most definitely a quadratic. Okay. On your homework, it's going to tell you which model to use. Okay. So the thing with the homework tonight is just getting comfortable putting the information in the table, typing in that regression model, then using it to answer the questions. So, number 6 and 7. You've got those tables to put in. Come up with a model, answer the question. The other thing you can do, if you want the color to match the points, you just hold it down. You can the color matches the points. Entirely up to you. All right, so write a regression model that best fits the data, rounding all coefficients to the nearest 10th. So our slope, 28.7, already rounded for us. Our y-intercept, again, nicely rounded for us already to the nearest 10. So when we go to write that, y equals 28.7 x plus 112.7. Using this equation, find the projected profit in thousands of dollars for 2028. So again, keep in mind, this 0 year, this is 2020. So for 2028, we're going to put in 8 for x. and round to the nearest $1,000. That means no decimal places. So our final answer here would be $342,000. So each of these numbers, that's $114,000. So instead of having to graph 114000 and all those great big numbers, they just took off those three places and just left the thousands, the 1,000, the 10,000, the 100,000 place. So $141,000. So then they would earn $342,000. Okay. So paying attention to what the units say about the table, that if they've taken off some of those place values in order not to have to graph some of those bigger numbers that way. Okay. Questions on that one? Okay. All right. So then looking at the next one, if we go back to Desmos, I'm going to take this graph off, this off, that one's on. So I'm going to go to that. Because I don't want to see the green. This one I would actually see it. Maybe not. Yeah, see. It's scaled so far out, they're there. So if you just click on the color, it turns that off. It's still there, but it just turns it off. Very clearly, we would want to use a quadratic. It has that curve of increasing and curving back down. This time my table is x2, y2, so that's what I'm going to type in. Go ahead and delete that one. y2, a x2 minus h squared plus k. 0.997. It's a really good regression model. So my values. I'm only writing them on the board over here, so when I go to the notes, I can remember them. What do they want things rounded to? Nearest tenth. So A, negative 128.8. H, 25.5. K, 38.8. Are those correct? They're kind of fuzzy, so is that what matches?
No, the point. No, the point is 0.6.
Which one? Which one? Oh, which one? Okay. Oh. Okay.
Yeah, I made that mistake too.
Okay. 38,825. 819. Okay, I've got 825 over here. Well, let's double check. Numbers. Oh, 75. Sixteen, 2, 1, 6. 4, 3, 4. 5, 8, 9. 3, 7, 6, 2, 1. There it is. All right. So that is. So there, this one's. So 3819.6. So 33.77 and 33.75. I typed in 77, it says 75, and it made a small difference to the K value. So just being very watchful, double checking your tables as you enter that information. So the model, y equals negative 128.8, x minus 25.5 squared plus 38,819.6. Use this equation to find the profit to the nearest dollar for a selling price of $36.25. So 36.25 So the nearest dollar means we're gonna round, no decimal places. So just watching again what you type, that'll get you into more trouble on these. Anything else, just watching those values. So I get the following amounts. So my final answer.
If you were to go through, do a 38.8, you would have gotten a negative number.
So the thing to watch, if we keep the selling price going, does the profit keep increasing? And that's a no, because at some point you're going to increase your selling price so much that fewer people are going to buy the item. So that's what you want to do with profit, is you want to maximize. So at what selling price can I make the most profit? It's not where can I sell the most items, it's where I can make the most profit. So even though I'm losing customers or the number of people that would buy the item, I'm still making more money than I would if I lowered the price. So, all right.